what could we do? Could we figure out the equation of that piece? What would be the equation of that line? Anybody remember? How to find the equation of a line? Yeah, y equals mx plus b. So what would be my slope? How many do I go up? How many do I go to the side?
3.
Oh, so it's like y equals 10 over 3x plus 0. Where'd you get the 0 from? It's the y-intercept. Good job. So now we can evaluate it and get the correct value. So 10 over 3 times 2, is that what you said? So that gives me what? 20 over 3. And what would be my units here? Meters per second. Velocity. How much is that? 20 over 3 approximately? 6.66666. Oh man, we would have been close. Maybe they would have given us credit. Runner B, how are we going to do runner B? Plug it into his function. I'm going to write it down here because later on I won't be able to see it up there. But we're going to plug it into the velocity equation here. So B of 2. 24 times 2 divided by 2 times 2 plus 3. So that's going to give me 48 over what? 7? And meters per what? Per second. So is this guy also running to the right? Yeah, he's running to the right at t equals 2, right? This guy's running to the right at t equals 2. Okay. The next question is asking for the what? Acceleration of runner A and acceleration of runner B at t equals 2. Alright, so let's do runner A. How would I find the acceleration of runner A? Finding the derivative of the velocity, which somebody said was the slope of the tangent line at, in this case specifically, t equals what? 2? So it'll be the same slope as that one? Because if I draw a tangent line there, it'll be on top of that one. So what was the slope of that line? 10 over 3, right? So that means the acceleration will be 10 over 3, anywhere in that interval actually from 0 to 3, right? So therefore we could say that A of 2 is equal to 10 over 3, and that'll be meters per second, what? Squared. Good? Alright. How about runner B? What do we got to do to get his acceleration? We need the derivative, so let's do it. What's the derivative of this function up here? Quotient rule. Okay, so I'm going to say it and you tell me what to write. Low. D high minus high. D low over low squared. Okay, do I need to expand it or anything, or can I just plug in numbers at this point? Just plug in numbers, right? I don't want to possibly make a mistake there. Alright, so let's find A of 2 for this guy. So that'll be 2 times 2 plus 3 times 24 minus 24 times 2 times 2 divided by 2 times 2 plus 3 squared. And this was calculator, so I could have technically just used my calculator to evaluate the derivative at 2, right? If I wanted to, but it's not hard, still doable by hand in case my calculator runs out of battery on the AP test or something. Cool? Or like if you had it in degree mode, but it should have been in radians. So what do we end up with? 7 times 24? 168, very good. You could do like 7 times 25, right? Because that's easier. But then you would have to take away what? 7? 24 times 2, that's 48. 48 times 2? 96 over 49? So So what's 168 minus 96? 72 over 49, and what would be my units? Meters per second squared. Again, it's acceleration. So what can you tell me about the speed of runner A and runner B? Is it increasing or decreasing at time t equals 2? So both of their speeds are increasing? Why? Does their velocity and their acceleration have the same sign? Should their speed be increasing? Runners, Paulina, should my speed be increasing after 2 seconds? Yes, when the race starts? Should I already be slowing down because I'm running out of gas? No, I should be speeding up, right? Makes sense. Unless you like broke a toe or something, and, you know, like you were taking off and your toe broke. And your nails were really long on your toes and it got stuck on the track. And when you pushed off, your nail broke off. Has that ever happened, buddy? No? Imagine. What would you do? Would you just keep running? Ignore the pain, right? Okay? Pain is temporary. Victory is forever. Alright, so anyways. The last example here. Something with trig, okay? And this is question number 3. So this is no calculator. So an object moves along the x-axis with an initial position x of 0 equals 2. The velocity of the object for t is greater than or equal to 0 is given by this function. V of t equals sine of pi over 3t. What is the acceleration of the object at t equals 4? So what do I need to do in order to find acceleration? The derivative of velocity, right? So a of t is equal to v prime of t. Can we find the derivative real quick? What's the derivative of Mr. Sines? Cosines, right? So cosines of pi over 3t times what? Pi over 3. We can't forget that chain rule, okay? Good? Now we got to evaluate it at 4. We want the cosine of pi over, actually 4 pi over 3 times pi over 3. What's cosine at 4 pi over 3? What quadrant is 4 pi over 3 in? Third. What's positive in the third quadrant? Only tangent, right? Okay. So we know this is negative. And what's cosine of pi thirds in the first quadrant? 1 over 2, right? So it's negative half times pi over 3, which gives us negative pi over what? Good? Too easy? So what does that describe about the velocity? What could you tell me about the velocity at t equals 4? It's decreasing, right? Okay, good. That's it, right? Could we say anything about the position? No, based off of its acceleration. Here we go again. Alright, part B. Consider the following 2 statements. Are either or both of these statements correct? For each statement, provide a reason why it is correct or not correct. Let's look at the first one, okay? It says from 3 to 4.5, the velocity of the object is decreasing. How would I know if the velocity of the object is decreasing? Didn't we just say that? The acceleration is what? Negative? Okay, so if v of t is decreasing, then v prime of t has to be less than 0. Is that true? So between 3 and 4.5, how would I tell if its derivative is less than 0? What would I have to do? Do a sine line? Like a test point? So what would be a number between 3 and 4.5? 4? Did we already do 4? V prime of 4? What do we get? Negative, so is the derivative negative? So should this guy be decreasing? Yeah? Are we good? Okay, great. So that one's true. How about the second one? The speed of the object is decreasing. What would that be true? What would make that true?
Both of them are different.
So V of t and
And they're different signs.
A of t have different signs, right? Okay, so let's check that out. We know that A of 4 is equal to V prime of 4, and we said that was negative pi over 6. So we have enough information there to prove that the first statement is what? Is true. But we also need V of 4 over here, right? So that way I can compare V of 4 and A of 4 for the second one. So how would I get V of 4? Plug it into the original. So that would be like finding sine of 4 pi over 3,
Radical 3.
negative radical 3 over 2, right? That's the other value, the other coordinate that we're missing. 1/2 and radical 3 over 2, and they're both in the third quadrant, they're both negative. Good? So they both have the same sign, right? So is the object speed increasing or decreasing? Increasing. So statement 2 is what? False. Alright, so let's write it down. Statement 1 we said was what? Correct. Okay? And we checked 4 because 4 was where? In the interval, right? So why is statement 1 correct? The velocity is decreasing, right? On the interval 3 to 4.5 because V prime of t is less than 0. Statement 2, that one was what? False, right? Or not correct. Why was it not correct? So if the speed of the object is what? Increasing on the interval 3 to 4.5 because V of t and V prime of t, which is A of t, have the same sign. We wrote why it was not correct. Do you understand? Super easy? Bless you. Alright, ready for your assignment? Not too bad? If I give you a velocity graph, how are you going to know whether the object is moving to the left or to the right? How are you going to look at that graph if I give you the velocity graph?
It's positive.
Where it's positive, where it's negative, or where it's 0, right? Whether it's below the axis, above the axis, or on the axis, right? That's how you're going to know whether the position was moving to the left or to the right or at rest. How would you know if the object is changing directions? On the velocity graph. You look at what's happening, right? When it changes direction. So that would mean the velocity changes from being what? Positive to negative. Not increasing to decreasing. You're looking at the graph run, okay? That would be where acceleration changes, right? So be careful, okay? Make sure you understand. If I'm looking for this, this is how I read this graph. If I'm looking for the next derivative, then I have to look at this graph differently. I don't look at it as positives, negatives, and zeros. I look at it as increasing, decreasing, horizontal tangents, vertical tangents. Understand? Sort of, maybe? Alright, so you'll have some practice problems to put all this together, and then that'll be it for today, alright? I'll walk around and help you guys if you have questions. But other than that, we are finished. Any other questions? Yes.
We could